Now let us continue writing our merge sort algorithm. What we need to do next is take the basic concept and apply it to working on a list where the source array gets merged without creating separate lists. What that essentially means is that we're going to take a big list that contains multiple elements and divide it into two subsections and merge those two subsections back into the same original list. So let's look at what we need to do to accomplish that task. First, we will need to create a temporary array that has the elements of the source array that we want to be merged. So, before we could do that, we'll need to write our method header. The merge sort header has already been written, but we're going to write another method that the merge sort method will use. So we'll start with the public static void keywords, and we'll just call this method merge. It will take a source array, and then it will take a series of parameters. The first parameter represents the left side of our list, or the start of the left list. So we're going to call it left start. The second parameter sort of represents two different things. So we're giving it a different name. We're calling it middle index because it represents the end of the left half of the list and the start of the right half of the list. Finally, we're going to give a final variable that tells us where the right half of the list ends. Okay. Now, if we look at what our step was going to do, it's first supposed to create a temporary array that has a copy of the source array elements to be merged. So let's do that first. We're going to create an integer array, and this integer array is going to be our temp array, and it's going to be a new integer array that has the same number of elements as our source array. This is, of course, an empty array at this point, so next we need to copy our values from our source array into our temporary array. Now you might think that we're going to copy the whole source array, but remember we only need to operate from left start to right end. So instead of I being equal to 0, it's going to be equal to left start, and it's going to continue as long as it is lower than our right end. And each time it will be incremented by 1. Then we'll give our temp array of I the value of our source array of I. Okay. Now, before we continue, we're going to put in a few other protective measures to make sure that this merge method doesn't ever cause an index out of bounds error. The first protective measure is going to check to make sure that our middle index is within the bounds of our array. So it's going to have a value that is less than we want to say that if it has a value greater than or equal to our source array, then we're just simply going to stop and do nothing. If this should occur, if the middle index gets a value greater than the end of our array, then our method is done and we don't need to do anything else. The other condition we're going to check for is to make sure that our right end value, if it should have a value greater than our source array dot length, In that case, we're going to simply set it equal to our source array dot length. And the reason for this particular check is that if you have an even power of 2 number of elements in your array, your list will always end nice and evenly with right end being the last element. But if you have any other number, you're going to have leftover elements. And this little check makes sure that you never go beyond the number of elements you actually have. Okay, so what happens next? Well, for our next check, what we're going to do is go back to our list and see what our next step is. Our step 2 is to merge the elements of the temporary array back into the source array until one of the subsections runs out of elements to be merged. So, let's think about this process. Before we had 2 separate lists. We still have 2 separate lists, but our list is actually made up of elements within one list. So our first list has the elements 0 at indexes 0, 1, and 2, and our second list has the elements at indexes 3, 4, and 5 in this example. So when our algorithm does our comparisons, instead of comparing indexes from 2 different lists, we're comparing the element at index 0 with the element at index 3, which is the first element of the second portion of this list. So, other than that, the algorithm continues just like it did before, taking each next lower value, copying it back into the array. The process looks like this with this sample list. If list 1 is 2, 3, and 5, and list 2 is 1, 4, and 6, then first 2 and 1 get compared, and 1 gets put in the very first position. Then 2 gets put into the second position, 3 goes third, and so on down the list. So let's look at how we do that in Java code. So, put some blank lines here. Okay. So, now we're going to start with our while loop. Just like before, before we begin, we need to set up some index variables. So, we need our left index, which is going to represent the current position in our left or list 1. So, it's going to have the value of left start to begin with. And then we need our right index. And it gets middle index as its initial value, because remember, middle index represents both the end of our left list and the start of our right list. Okay, and then we also need to know what our current copy position is within our original list. And that always starts out with our left start value. Because our array elements are going to get copied back into the source array, starting from the same place where we started with our left half of our list. Okay, now we can write our while loop. So, we're going to say that as long as our left index is lower than our middle index, then we want to keep going. And if our right index is less than our end point, the end of our right list, then we also want to keep going. Now what we have to do is compare the values at the 2 positions in our list. So we're going to write our conditional statement. What goes inside the parentheses? Well, first, we're going to look at temp array at the left index position, and we're going to see if it has a value lower than our temp array at the right index position. And then it's either going to be less than or greater than. If it is less than, then that's the value that we want to copy back to our source array. And where do we want to copy it to? Our current copy index. What value does it get? Well, it gets temp array left index. And because we've used left index, we need to increment it so the next position in the list will be checked on the next pass of the loop. And the same thing goes for the right half if the right half of the list contains the lower value. But instead of left index, it's right index. And in that case, we need to increment our right index counter. And in either case, we've added an element using current copy index, so that needs to be incremented. Now, remember that in this example, it will go through each portion of the list until one of the lists runs out of values. In this example, that leaves one value, the final value, yet to be copied. So that is represented by step 3. Copy all the remaining elements in the temporary array that did not run out of elements back into the source array. So that's what we're going to do next. And just like before, that's going to be a while loop. Now, since we don't know which list is emptied, we first check to see if left index is still lower than middle index. And if it is, then we copy to the source array at the current copy index the temp array value pointed to by left index. And then because we've used left index, we increment it. And in this case, we've used our current copy index. So we increment it as well. And if it happens that our right list is the one that still has values in it, then it will have a value lower than our right endpoint. So we'll copy from the source array the current copy index from our temp array at right index. And because we've used right index, we increment it, and we also increment our current copy index because we've used it. Okay, now all that remains is to return our list, which happens without us having to do anything. So this completes our merge method. But notice that our program doesn't call our merge method. It calls MergeSort. And this is where we have to actually put our code that calls our merge method. We can say that the merge method takes care of the divide portion of our list, or rather, I guess you could say it takes care of the conquer. What we have to do now is actually divide the list. So let's look at how we do that. Down here is a diagram that shows this process with the example data that we have in our program. What's going to happen is, remember, our merge method only merges lists that are already sorted in order. But if a list only has one element in it, by definition, it has to be sorted in order. So if we start by looking at lists that have one element and merging those two lists together, we can say that we can safely merge them. So first, we're going to merge the first two elements in our list, giving us a list of two elements back that are sorted. Then we're going to merge the next two elements, putting those in sorted order. And then the next two elements, putting them in sorted order, and so on. If our list has 16 elements, we have to do this 8 times. Now our list has pairs sorted in order. So what we could do is merge this pair of two elements with the pair of two elements next to it in the list, giving us a list of 4 elements all sorted in order. Repeat that process for the next 4 elements, and we get them in order. On the next pass, we'll have a list with 8 elements in it after we merge 4 elements and 4 elements, giving us a total of 8 elements all in order. We're almost there. For our last pass, we merge the left 8 elements with the right 8 elements, giving us a total sorted list of 16 elements. Notice that in each pass, the size of the number of elements that we're merging doubles. First it's 1, then we're merging 2, then we're merging 4, then we're merging 8, giving us a list of 16 totally sorted elements. So let's see how we write that in Java. Okay, so what we're going to do first is take this progression here. And what we're going to do is write a loop. And we're going to say, how many elements are we going to have in a block that we're merging? We start with 1 element. So we're going to say we have a block size equal to 1. Then we're going to have this block size increase until it's, as long as it's less than the size of our array. And finally, what's going to happen to block size each time? Well, the first time our block size is 1. Then our block size becomes 2. Then our block size becomes 4. Remember, a block is how many elements are in each half of the merge that we're performing. And then 8, and then we're done. So, what happens to block size each time? Well, it gets its old value times 2. Each time it gets doubled. And a shorter way to write that is to say that it is times equal 2. Okay, now what we have to do is actually call our merge method using this block size to repeatedly merge our small lists. So what we're going to do is write a loop that says our left side, or our left start, is going to be equal to 0 when we start, and each time, you know what, we'll call it our left index, just so it's the same name that we used in the document. So our left index is going to start with 0, and it's going to keep going as long as it's less than or equal to the array length. And then each time, our left index is going to increase in value by the block size times 2. So why did we choose these values? Well, our left index for our first merge is 0. When our block size is 1, what's the index for the next start of our next block? This is index 0, 1, and 2. If our block size is 1, we need to go from 1 to 2. So our block size is 1, we double that, we add it to our current block size, and we get to 2. On the next pass, our block size is doubled. So our left index jumps from here all the way to here. Each time, it goes up by double the current block size. Now we're set to actually call our merge method. And this is where our values need to be calculated. I've made a chart to try to illustrate how this is going to work. So, when block size is 1, our initial left index is going to be 0, then 2, then 4, then 6, then 8, 10, 12, and 14. Each time it's increasing by 2. And when we call our merge array, our merge method, the first thing we need to pass it is our array. The next thing that we need to pass it is the start of our left side of our list. And we want to merge starting with 0, so we're going to give it our left index. Then for our second value, which is our middle index, well, in this case, it's going to be the left index plus the block size, because each time it starts at left index and goes for as many elements are in the block that we're merging. So it's our left index plus block size. And then finally, what is our right value? Well, it's going to be the end of what we're trying to merge. So it's going to have the left index value plus 2 times the block size. And now we will be calling the merge method in this pattern that you see here. When block size is 1, it will get 0, 1, and 2, then 2, 3, and 4, 4, 5, and 6, and so on. When the block size doubles, the number of elements doubles, so it starts with 0, goes to 2, and then ends at 4. Okay, we've now written all of the code necessary to actually see this process in action. Our next step is going to be to try to follow the code to see what it does. So we're going to watch each time the merge method gets called. And to see it function and see what the array looks like each time, we're going to put a stop right on this portion of the for loop so that we can see what the array looks like each time a merge is about to be performed. And then we're going to run it in debug mode. Now, at this point, I can click on ARR to see the current values in the array as it stands. So, if you look at your sheet of paper, hopefully you have a printout, I would suggest that you should go back to this diagram, because this is what we're going to see happening. Our merge is going to follow this pattern. First, it's going to compare 3 and 2 and swap the values 2 and 3. So I'm going to hit the resume button, and as you can see, 2 and 3 just got swapped. Remember, our block size is 1, and our left index is currently 0, but now we're going to go through the next iteration of this for loop. So left index is about to become 2. And it didn't need to swap 1 and 4. That's these two elements. So you didn't actually see anything happen. But the values did get copied back into the array. 13 and 10, our next two elements, will need to get swapped. Then 12 and 15, that's going to be these two, but they stay the same. 9 and 6 do need to be swapped, so we're going to see those two switch. And then 11 and 7 will also switch. 5 and 14 will stay, and 8 and 16 will stay. Now, on the next iteration, our block size should go up. And now we are going to see our 2, 3, 1, and 4 get merged together. So, our block size is now up to 2, and when we run this, we'll see these 4 values get put into numerical order. Within our page, we're at this point of the program right here. We're about to merge these 4 values, giving us this result. So, let's resume, and we get 1, 2, 3, and 4. On our next pass, 10, 13, 12, and 15 should get sorted into order. Then 6, 9, 7, 11, and then 5, 14, 8, and 16. And then our block size should increase on the next pass. And Now our block size is 4. So we are now at this step of the process. We're now going to merge these 4 with these 4, giving us a list of the first 8 elements all sorted in order, and the second sorted in order. Okay, then our block size is going to increase to 8. And this should be the final pass required to get our list completely sorted. And there we have it. Our list is completely sorted. I'm going to switch back to the Java view and run the program. And you can see the results right here. Before, this is what our list looked like. After, this is what our list looks like. This is a complete merge sort algorithm.